Hello everyone, welcome back to Emmanuel Tutorials. Today we'll be seeing a doubt asked by one of our students in the comment section. This is related to signals and systems, sketch the signal type, and this is particularly a ramp type of signal. If you have not subscribed to Emmanuel Tutorials yet, do subscribe and do like and share this video with your friends in need. And if you also have any doubts related to electronics or computer science engineering, you can let us know in the comments and we'll try to help you. Let's start. So this is x of t and we have to draw an addition of r of t and 2r of minus t minus 1. So this is a simple ramp and this is a shifted and reversed ramp signal, and along with it there is amplitude scaling as well. So first what we have drawn is the ramp signal. So ramp signal starts from 0 and goes up to infinity and has amplitude of t at t equal to 1, 2, 3 up to infinity and t equal to 0 as well. So at t equal to 0 amplitude is 0, at t equal to 1 amplitude is 1, and so on, and we get a 45-degree line across the x and y axis. This is r of t. And then to draw the second part of the signal, that is 2r of minus t minus 1, by a precedence rule, it is shifting, scaling and time reversal. So shifting meaning we'll first shift the ramp signal by 1, and it's a minus, so it's a delay, so we'll be moving it to the right by 1. So r of t minus 1 will be this signal. So it will be the same amplitude but only shifted to the right by 1. So now the signal which appeared at 1 will appear at 2, which appeared at 2 will appear at 3, and so on. So this is the signal that we will be having for r of t minus 1. Next, what is left is the amplitude scale, the time scaling, or you can call it reversal as well because it's a minus sign. So what I'm going to do is just reverse the signal across the x-axis or the time axis to get this signal. So amplitude at 1 will be the same amplitude at minus 1, amplitude at 2 will be the same amplitude at minus 2, amplitude at 3 will be the same at minus 3. So we have at minus 1 amplitude is 0, at minus 2 amplitude is 1, at minus 3 amplitude is 2, and so on. And we have one more operation which is to be performed, that is 2 of r of minus t minus 1, which is amplitude scaling. So whatever amplitude is here, we'll be just multiplying it by 2. What will we be getting? At 0 or at minus 1 it will be 0 into 2, which is 0. At minus 2 it will be 1 into 2, which is 2. At minus 3 it will be 2 into 2, which is 4, and 6, and so on. So that I have just drawn it as a dotted line. So this is what we are going to get as the resultant for 2r of minus t minus 1. And then x of t is the addition of ramp signal with this signal. So it's just a simple addition, and if you see there is no intersection between these two signals, so you can just draw both of the signals as it is, and this is the resultant which we will be getting. So from 0 to infinity, and this signal is going to go from minus 1 to minus infinity, and its amplitude is going to be 2 times of the ramp signal. So at minus 1 it's going to be 0, at minus 2 it's going to be 2, and minus 3 is going to be 4, and so on. So this is the resultant signal that we have to draw for the given question. So hope you understood this. If you have any doubt related to this video or any other concept in electronics or computer science engineering, please let us know in the comments and we'll try to help you with that. Thank you for watching.